Personally, we have started during COVID time. So during COVID time, we have our team members. We don't have work for customer side. So we started working on inspection automation or Industry 4.0 type of inspection. There we started our journey, and really it is helping on zero defects and customer satisfaction, and a customer our where we are working our brand image improvement, everything happening by achieving zero defect. So, as a team, in national teams, we started this type of automation, online inspection, or communication to a customer. Everything as a team, we started. Some maintenance people, some of planning people, and design, from design quality. So everyone we started working on automation. So automation inspection or automated inspection we started. There, some of the case studies we have done. It is successfully we have launched in different customers, and customers are also happy, and customer also want to see the automated online inspection process through network in their area. So we have now started working on IoT. So in IoT side, Omnex is a multinational company. They are doing third party inspection, and they are doing training, Six Sigma, or all quality related projects they are doing. So we started working with Omnex for IoT. So this is the starting point on automation to customer. So from Chennai, at USA, they can see our product quality or our product production line capability. Everything they can see. That type of work we have done through Omnex. Mr. Hemant is one of the person who coordinate with us. Similarly, from Ashley L teams, a lot of people supported. Mr. Arasan from design and maintenance, Mageshwaran, and PPC, Gautam, Sabri, and the quality side, Ramesh, Swaminathan, Jagdish, and so many people supported. So without their support, this presentation is not at all possible. So I thank everyone who supported on this presentation or automated online inspection. So this is the journey I have communicated from 1784 till now. This is industry is moving on. Now industry 1.0, 2.0, 3.0. So now we are in industry 4.0. And Industry 4.0 now connects an embedded system, production technologies, and smart production process to pave the way to a new technological age, which will radically transform industry and production value chains and business models. No, this is really we have connected. We have done a lot of improvements, and we want to highlight to our customer, or also customer also one of the customer comments. Really they are interesting on some of their products. They want to see complete online verification. And many customer now, they want to before doing dispatch, they want to see the casting quality with respect to visual or dimension, whatever it is, they want to see online. Some people they are having one-to-one camera system. Some people they are using a cloud system. So achieving zero defect, Industry 4.0 really helping on cost reduction, customer satisfaction because of the data transfer is fast and cheap and also transparent with quality. So the total customer satisfaction is happening. That is the main advantage. So in fact, maybe initial investment during COVID time it was high with respect to sensor or automation. What we are doing, automation according to the customer requirement or drawing requirement. That cost is that point of time it is high. Now the cost is really reducing. I am talking
Uh,
about investment cost. This is one case study we want to tell. This part is connection adapter. One is the part connection adapter. This part is Cummins they are using. So local, domestic, and export both the component is going with different drawing dimensional and also different part number. In this, this is the part we started working. This part having 14 critical parameters. That means CP, CPK parameters are 14 parameters. So normally we started working on CMM. Generally, the CMM verification initially. After during production also, CMM shift once or shift to twice like that. But we want to do 100% inspection and 100% CPK value. Customer want to see. Similarly, we want to also monitor. So we started working on accuracy. Accuracy, 1 micron accuracy, we want to do. So we, searched, with the support of people, we searched in the market and we have identified, many sensors. And I will, show some of the sensors available in the market. But in this case, we have used, LVDT probe and no sensor. The sensor means laser sensor. This sensor we have used, and the characteristics with respect to specification here we shown 14 parameters are CP CPK dimension. So earlier we used for some on production line we used a plain plug gauge, some of the thread plug gauge, height gauge like that, and the CMM, partially CMM. So the part mix up with respect to family or part number or model. So that is 100% dependent on visual inspection. So to avoid everything, visual inspection or 100% thread plug gauge inspection or height gauge inspection, then flatness measurements or position verification, all are we have done through CMM. So the CMM inspection time is high for doing one component almost 15 minutes it was taken. And we want to reduce drastically, and for the purpose we started working inspection time reductions that we achieved from 15 minutes to 1 minute. Similarly, the frequency, every shift once, every shift to twice, we have checked. So instead of five numbers, random inspection or patrol inspection or firewall inspection, sometimes some of the critical parameters out of 14 critical parameters, some of the parameters we have checked 100%. So this is really pain and manpower also manpower means trained manpower required during inspection. A lot of dent and damages are happening, and sometimes the thread breakage when they are checking they are damaging the threads. Similarly, a lot of disadvantage are on no, in the shop floor. We found many rejections. So to stop internal rejections, and also to reduce inspection time. And also we want to increase inspection frequency. Almost we have increased 100% inspection frequency through automation. So we want to know, first we understood what are the requirements with respect to drawing requirement. Drawing requirement, what are the major parameters or critical parameters, CPCPK parameters we have identified. Other than that, what are the end customer touch point? So generally, quality people during project launch or during project technical review, they will discuss about all customer touch point or end customer touch point, what their end customer is looking. So everyone we collected and we put and arrived critical parameters. The critical parameters are agreed with customer quality team members. Similarly, customer engineering members. We have agreed the dimensions. These are the dimensions we are going to address. It is covering all drawing requirements, critical requirements, and also customer touch point. So we have discussed and now completely finalized the requirements. Then we worked on how to the customer want to see, because after COVID, no customer coming for audit or verification. No, they are not coming. But no, we want to show all the information, drawing, print, no information, dimensional information. We want to give to customer. That also we want to give through live data. That we have connected with cloud. Through cloud, they can able to see in their in their factory in computer through Excel sheet. This is the way we worked. So I want to show some of the video. So this is the probe is fitted on top. Sensors are fitted on all the sides. So all the 14 parameters are checked. This whole position, whole presence. So everything we have checked, and also flatness and thread presence. This is each and every process we want to have OK master, not OK master. So before starting, the operator should check the machine is working well or not. So without component, the operator just to check it there, place the component, the alarm is there. This is the model part number verification also. If the export component or domestic component, that information also coming there. If everything okay, there the green verification is green color indication is coming. And also the each and every component, the traceability and live data stored and interfaced with the customer system. So doing this, we started working. We achieved really zero rejection month on month and year on year. That is the major success with respect to this. And the total investment approximately that point of time 12 lakhs, I think. The same thing, if at all we want to do now, maybe 4 to 5 lakhs required, the total investment. But the investment is almost reduced by 35, almost 70% reduced. But no, the manpower earlier we have more manpower with respect to 100% inspection. But the manpower also we have reduced, and the customer also happy with respect to this type of automation. and customer wanted to implement in all their castings. But we have done all critical components, not 100% of our component, but wherever the critical dimensions are more, there we have implemented. This is one of interesting case study. So I will move to case study, second case study. This is is another case study. Earlier I have communicated that a lot of low cost sensors are available in the market. Here the low cost sensor I'm indicating to all our foundry die casting friends. The color sensor, touch sensor, ultrasonic sensor, alcohol sensor. Is alcohol sensor normally we have implemented during gate entry. So people, alcohol, used, operators or people are coming inside before we have given the sensor to the instrument to security. So they have controlled. They will send the people to medical or HR. This alcohol sensor, low cost sensor is available. Similarly, humidity sensor. See, humidity sensor, all inspection standards room required. Similarly, air pressure sensor, gyro and acceleration sensor, hall sensor, soil sensor, proximity sensor. Heartbeat sensor, we have not used some of the hospitals they are using. So infrared sensor, IR receiver, temperature sensor, light sensor. Light sensors are commonly everyone using. So light sensor nowadays built in with light itself. Then load sensor. Load sensor, whenever we are applying load with respect to bearing pressing or bush pressing or some of the pin pressing, there we are using the load sensor, low cost load sensor. Similarly, pulse oximeter. Pulse oximeter, so during COVID time, it was, very known one. Now the pulse oximeter, is, and the cost also, reduced drastically now. Then gas sensor. Gas sensor, normally we are using at kitchen, in canteen side, where LPG we want to detect leak. Similarly, LPG bullet, where we are having outside, there we are using gas sensor. Similarly, sound sensor, tilt sensor, rain sensor, PAR, motion sensor, auto speed sensor, flow sensor. These are the sensors are available in the market. So made in Taiwan or made in China, it is available. Most of the sensors are available made in India, make in India. That sensors also available in the market now. This part, this is the part, our flat part, only drill and taps and some of the holes opening, some of the thin fins bend. This is a bend prone component, warpage prone component. So here, we have each and every component, bend inspection itself, very difficult. At the same time, we want to check. We want to send the customer such a way that every day 1,000, 2,000 numbers. Very practically, it is difficult. And we have introduced inspection automation in this component, in the thin wall thickness component. Most of the this is a 2 wall thickness component, and I will show the video how the video works. So before, this is like, okay, okay component, okay master, not okay master. Similarly, we want to check, we want to calibrate, make it zero. This we have made. Each and every shift we need to verify. Set zero. So now the operator made set zero. These all probes made set 0. Now the component with respect to customer touch point or customer assembly requirement, this is the okay part. So we have designed the fixer bottom side, top side. All sensors are mounted. The previous video, all sensors are mounted everywhere. This case, top side. So okay, also punching. The component is okay. The green paint, green paint mark painting is done. This is the way the all the required 5 locations are checked. The flatness is 100% ensured. Similarly, all hole openings, all thread presence, all pitch, hole, the mounting holes, pitch, everything checked in seconds. The component is not okay with respect to bend or hole blockage. Hole blockage, straight away component will not sit in the fixer. So with no green point, with the green paint, operator will directly pack the component. This is one of war page and all hole presence, flatness, thread availability. Some of the even fettling defects. That fettling defects also can be captured because the fixer is designed such a way. This is case study 3. So case study 3, now we want to use this is aluminum component is assembled with 3 parts. So the component is aluminum. The 2 bushes we are using. The 2 bushes are plastic with a different color, black color. Similarly, one pin bush also we are using, that is stainless steel. So we want to check during assembly everything available or properly assembled, or if anything missing. So everything we want to check and confirm to customer. That is the customer requirement, because this part is directly used in one of car manufacturer. Is very critical component, gearbox component. So they don't want even single part rejection, because the end customer only going to test. So a tier 1 going to do only assembly. So tier 2 car manufacturer, they are going to test. If the bush or if the pin is missing, totally, they will get huge noise during production, during testing. So to avoid this, we have introduced color sensor and photo sensor. So color sensor to identify all the parts are available, and photo sensor is properly fixed. This both we want to verify in one single fixer. The fixer already we are using for assembly. The same fixer we have used, only we have implemented photo sensor and color sensor. Just I show the video to understanding purpose. This plastic part, black color part, aluminum is this we use the color sensor here. You see, this is yeah, fixed in the fixer. For demo purpose, we have shown. This is without bush. Without bush, the reading C 5. This is the color identification is giving signal to operator, and also further operations. Further operation will be stopped through this, because after this, after assembly only, we need to press the bush. So without this one, the entire operation will stop. This is 0. The plastic part is available. That means the green signal is there. The green and red available. This will be interfaced with the our system. The photo sensor I want to show to all our Foundry friends. This is mounted on the fixer. See, the part is missing. Then assembly will not work. Now the getting signal, green, red, and the signal is getting. So the part is present, then the photo will automatically detect within simulated time. You can see now the flashing. So now the assembly we have completed. This is not an no assembly line. No, for understanding purpose, we have taken outside because during assembly, finger injury may happen. So we want to show to audience how it is working. So we have taken outside the line. This is another case study. Uh, here, this is in the machine shop. We have implemented in the machine shop. You can see the flow chart here. This is a start. We want to check the casting. The casting is okay with respect to some basic dimension. So incoming inspection is required. So the incoming inspection will be done by operator in the quality station. So in the quality station, you can see, so all air sensor, gauges, plug gauges, everything is available. This is all having interlinked with each and every machine. For example, incoming inspection linked with VMC first machine. Similarly, VMC whatever output is linked with VMC two machine. So this line having four VMC machine. So all four machines are linked with the quality system. This is the quality station. Here we are having we are having total four VMC, four operation OP10, 20, 30, 40. So all master samples are available, and incoming inspection on components also available. So operator will check if it is passing. He will move the component to VMC1. If the component not passing or not achieving the quality, the operator will put there is a small we have made a component reject component we want to put at the same time we want to account how many components are rejected, and also we want to avoid mix up. The component will go this chute. This is a simple PVC pipe we have simulated. The component will the rejected part will go this way, and no, in the back side we have red bin. It will be uh, in the red bin. The red bin is totally closed. Once the rejected component there is enough taper is there, the components follow on the bin, red bin. And also, this is the simple diagram we want to show. There is a receiver and emitter, and this the rejected component during flow. This will account how many components are rejected. Similarly, from VMC operation, once we completed all dimensions with respect to dimension, concentricity, everything checked through this station. Each and every station, the same arrangement will be there, so that VMC one producing good component or bad component, immediately we can stop. Then this component will be stopped in that VMC itself. Operation 10 itself we can reject. So that the last operation after completing all operation, the component rejection is totally avoided. That is the one no advantage, and mix up and other things totally avoided. And following this, in the chute, the go, this is okay. The red way, the red bin. Similarly, for okay component moving also, there is a there is a chute here. there 100% it will be accounted, and through that we'll complete all the operations without mix up, without dimensional issue. Through that achieved zero defects in this case. This is the machining line. So machine line interfaced each and every machine with the help of quality station. So I'll move to another case study. This is another critical component which we have on ASCAS dimension and some of the machining dimension. Here parallelism also here important. Barcode label is interfaced. So you can see here list of parameters. So 14 parameters here: double position, overall flatness, double depth, double outer diameter, thread assembly, M16, M8, M6, M10. Similarly, part mix-up. There are three models are available. We want to avoid that also. Similarly, height, one of the important height, then parallelism, then total overall thickness, then multi-gauge verification punch. So customer want to ensure the component is checked 100% through this automated online inspection. So customer want to identify traceability, that also linked. Finally, barcode will be, if everything okay, the barcode will be coming out on the machine, and the same barcode will be pasted on the component for customer reference. This is simple station, and the PLC how it is all the dimensions are now captured with the green color. Similarly, yellow is our next operation, barcode printing, whatever that everything interfaced here. There is a barcode printer here and also scanner here. This will be scanned the traceability, everything stored in the data. Yeah, the data will be transferred to our system, or through our system cloud system can be seen by customer. So for understanding purpose, I want to show this video. Hmm? Video is visible. Hello.
No, sir.
So your screen is
No, sir,
visible,
no,
but
sir.
video has
No,
not been played.
no, not visible.
Video is not. No. Wait a minute.
Now it's fine, sir.
Now it is no, visible.
Yes, sir. Yes, sir.
Okay. No, some of the people, no, some of our friends are typing uh, some maybe some questions, or I don't know. Maybe I will answer to all the requirements during end of the presentation. This is barcode label is coming out after inspection. This it is pasted again, scanned. So everything recorded there. The traceability. So everything completed in less than 1 minute. This is case study 6. No, this is every die caster or every machine shop people having CMM. We want to use the same CMM with small improvements with respect to CP/CPK monitoring. So every shift or every day we are doing inspection. All the critical parameters or CP/CPK dimensions are recorded, and automatically CP/CPK dimensions will be data available for our operator. The CPK or CP value is less immediately each and every shift. This is accumulation of few days or few shifts component, but each and every five component we can communicate to shop floor people for correction, whatever it is. Here what we have done, we want to so generally CMM inspection is normal time. So they do, we make our own fixture and we do check. But this case, customer, how they are assembling the same thing with the same torque value, the same type of fixture we have made in the CMM, and the component is mounted in the same way, so that the same, same thing, the same component with the traceability, customer can check and verify the same value will be. Value will be met. So our value will be equal. That is important. Sometimes I'm checking this way, a customer is checking another way. This confusions will be avoided. So customer, how they are doing assembly, what type of how many bolts are using, what type of bolt, what torque, everything we have done in the CMM, so that whatever we are checking every day, every shift, during patrol inspection or first off inspection, everything data will be shared to customer by CP/CPK value. Customer can see the same in their system. I'll move to next case study. This is shop floor in die casting machine. A lot of sensor we have seen earlier. So all sensors are connected with respect to requirement. For example, we want to identify downtime, how the productivity is going, how the quality is there. Then what are the parameters we have optimized? The optimized parameters are all 100% adhered or not. And also with the low manpower or lower cost in the shop floor, we can deploy. And capacity also we can no, capacity gaps or capacity cycle time, everything we can verify. Similarly, the maintenance person can verify all the input data like downtime, everything, why downtime. So everything everything can be monitored, controlled, improved through this sensors. The sensor will be connected to router. The router will give communication to system, our own quality system, or computer, or own PC. Then that will be moved to cloud through IoT. The cloud space, a lot of free cloud space are available, or paid service also available. We can use. Similarly, the same everything will be monitored by customer. This is we want to implement in the shop floor in die casting machine or CNC machine, to identify some of the critical parameters like temperature, or pressure, or vibration, or oil level low, high, or that type of is all the things we want to control in the shop floor in the die casting machine or CNC machine. Next. And this is some of the critical IoT work point connected sensor fixed on the motor. So normally the coolant motor or power pack motor, both are important for CNC machine accuracy. There the motor temperature or hydraulic pressure, hydraulic temperature, hydraulic pressure, both will be monitored every every few seconds, every seconds we can monitor. So continuously we can monitor. At the same time, any abnormal things, the temperature is going up or pressure is going down or up, so immediately we will get communication through SMS. So most of our supervisors are doing troubleshooting in the shop floor. They can get immediate continuous messages. So each and every cycle, the message will go to mobile. This is the way we have connected all the parameters like oil temperature, oil pressure, panel temperature, vibration on spindle, vibration on foundation, or vibration on fixer, vibration on tool. So everything we can monitor. These are some of the photographs where fixed for your understanding. I have shown here. Next. This is the machine vibration monitoring. It's automatically see the 160745, 160750. So this is the way the each and every continuously it is monitoring. So these are complete live data we can get. This is not live data. This is live data taken from each and every CNC machine. Similarly, temperature, vibration, so everything we can monitor. See, there is an up and down, maybe because of this. See, the level is a 42.25 and 42.7, small variation, but still all variation, even small variation in the temperature. For example, zero point 0.5 temperature, zero point 0.5 degree temperature also it will detect. The sensors will detect and record. Next. This is a die casting, the die casting process is interesting. Many people struggling on shop floor because of multiple parameters and variable parameters or semi-variable parameters. So we are trying, we are trying to reduce the variation. So variable parameters will be, controlled by, semi-variable parameters. Similarly, semi-variable we want to, fix. We want to change to, fixed parameters. So this is the success of quality or success of productivity. So normally variable to semi-variable, semi-variable to fixed. So if the all the parameters are fixed, then our process is stable or fixed. Here, some of the photos, shop floor we have implemented. This is once in a metal level low, the level is low, automatically signal goes to melting department. This is the machine, HPDC machine and melting shop is connected through some interlock. Once we don't want to get low amount, we don't want to stop the machine after empty. So during low level itself, indication will go to a melting department, so that melting department will pour the metal before empty. This is one type interlock we have done in the holding furnace to melting shop. Similarly, is degassing control. So in the degassing is after melting, degassing nitrogen pressure regulator and pressure pressure regulator is low or high. That we can monitor control. It will stop the machine. The degassing will stop, and at the same time operator can visibly see. At the same time, supervisor can get live information. Similarly, metal temperature locking. After pouring in the holding furnace, metal temperature locking, the auto ladle will stop. Some that picture also I have connected here. Essentially, the uh, cursor. So this metal temperature, interlink we have done. So in die casting machines, normally customer giving most of the critical parameters, and we can add some of the it is available. It is available on the system. We can demand our machine manufacturer, and we can add the number of rejection parts counting, and the temperature, because of molten metal temperature, how many hours the machine is stopped, everything we can take. This is some of the improvements in the die casting side. I'll show some of the videos for better understanding. The screen is visible. Hello, screen is visible.
Yes, sir.
Okay. See, normally these, the sensor, additional sensor, just we have added, everywhere. The system is already available. Some of the sensors only we have added. Yeah, this is on sensor. This is flow sensor. It is also no, because of no, the nitrogen cylinder empty is getting alarm. The alarm will be triggered to the degassing unit will stop and giving a communication to supervisor or operators. So I interlock வேண்டாம். You can show rejection part. This is parameters and rejection accounting with respect to process parameter, how the component is rejected. We have different shoot, okay part one shoot, and not okay part one shoot, and the same thing accounted in the machine. End of the day, how many parts are rejected because of process parameter variation, that can be taken. This is NG part. This OK part normally come to shoot. The rejection part go to straight away red bin. This is one of the requirement of Maruti. Maruti, whenever Maruti comes for audit, or Maruti suppliers, tier one supplier, tier one customer comes to tier two supplier. This is the basic thing now they are expecting. Next. This is die temperature. Die temperature, one of the very critical parameters in die casting. With respect to temperature, the defects increasing. Temperature low also problem, high also no problem. Within the level we want to, within the band we want to maintain the temperature, means the flow system should be water flow system should be perfect. So we need to monitor the flow, and we want to control the flow. We want to control the temperature. So all the big unit, this common unit, the total income water, and how many die cooling spots directly connected. Temperature also we can control. We can set and control. Similarly, flow also we can set and control. This is the unit available in the market. Some of the so like Sundaram Fasteners, they are demanding this. We have implemented for for our die casting. Each and every machine we have. Some of the people calling this water battery. This is one of the improved system. In water battery, we can see only flow, but here we can see flow also temperature. And traceability. So traceability, traceability is important with respect to rejection control, or achieving zero defect. So which operator, which shift, which machine, which melt, which die casting machine, which CNC machine, which operation, which assembly. So everything we can control through casting traceability. So traceability is important. This is a starting point for the for any die casting component. But I am showing here at the last because so everyone will remember that traceability is important. So traceability, a lot of traceabilities are there with respect to this one. The latest is laser marking, laser marking. This is the one we have implemented latest. Now, some of the customers asking laser printing. Some of the customer is asking barcoding. Some of the customer is asking calendar mark. But traceability is important everywhere. Next. Similarly, in CNC washing, some of the interlocks at the same time, the potential rejections, happening where it is happening out of machines. So normally, the coolant flow, the coolant system is some of the machines. So the coolant system, CNC machine coolant system is inbuilt. Some of the system coolant is not inbuilt, it is outside. So where we want to get operator message with respect to coolant pressure, coolant flow, so everything. So this will be interlinked through because a lot of things are available in the old machine itself. So we have called the machine manufacturer, whatever we can set to stop the defect producing. The prevention fail safe we want to implement in the shop floor, so that we have implemented a lot of things in the old machine itself. This is some of the example. This is fail safe with fail safe prevention because of spindle overload and feed rate high, and the coolant flow is less, or pressure is low, or flow is low. Machine will be stopped and the operator used to get a message. And now similarly, this is a washing machine. The contamination with respect to oil, dust, dirt, that contamination is high. At the same time, temperature also important. The temperature is the washing record. So the soap water records some temperature. That also we can get during washing. That interlock can be done. These are very low cost automation. This another one is the component seating. This is a seating sensor. Most of the machines now, new machines are coming with probing system, or air pressure sensor. The component is completely seated with respect to datum. Whatever datum required, the datum is completely seated or not. That is available in the new machines. For old machine, we can do the same thing in the fixer itself by providing point 2 mm, 0.2 mm hole with connected small this one. The air is escaping, so that the air pressure getting low means the component is not properly seated, and the cycle immediately stops. So that is the arrangement we have done for old machine. New machine we can take directly the probing system. So I want to show this video. Yeah. Okay. This is the probing system. Similarly, this is in the component where it is mounting, that we can check. We can put the probe in the fixer itself. Some cases in the fixer, some cases in the machine itself. We can link with the machine. This one, the pressure is getting lower, machine will stop. Next. So thank you. We can discuss whatever.
Thank you, sir. Gentlemen, if you have any queries, you can raise your queries.
Someone, Lakshman, asked, dear sir, I want details for casting stage digitalized inspection like camera detecting. Now I have shown one video with respect to assembly. So you mean assembly detection or what detection you are expecting? Casting stage digitalized inspection like camera detecting. So here the problem is the color sensor can detect in the open atmosphere. We can put color sensor in the shop floor, no closed room or the whatever lightings with respect to day and night lightings. It can be the camera color sensor camera will work. But with respect to some casting, some of the holes are broken, or some of the dimension deviation, or some bend. That type of detection we want closed atmosphere. That lighting. The lighting, no, lighting should be perfect. Lighting should be all 24 hours. It should be same level. Then the system will work. We have implemented one system that is not in the shop floor. It is in the lab. So we can put in the lab so that the component the image will be taken. For image, the camera lighting is very important. Lighting should be same at all point of time. Even some small variation in lighting with respect to uh, lighting model. Lux level. Lux level. Small lux level variation also indicate wrong information to us. So it is available in the market in Chennai itself. Some of the people are doing. They have implemented. Lakshman, I hope I have addressed for your question. Hello.
Is there any other questions?
Lakshman is not there. Okay. Any other question?
He has mentioned it's okay.
Any other clarification or questions?
Raman.
Good afternoon.
Hello.
Yes, sir.
Sir, good afternoon. This is Suguram from Address Engineering. You
Yes, sir.
explained, you very well explained the method of inspection from casting to up to reaching the machine shop. Yes, we are facing some issue in the aluminum die castings. Even very small porosity or blowholes after machining in the seal moving area. That is, we are finding very difficult to find out through even X-ray also.
Okay.
Since it's a seal moving area, this is not recommended. Is there any other method is there to detect in before machining stage?
So you want to understand the internal shrinkage before machining itself, right?
Yeah, correct, sir.
Okay.
It is not able to detect before machining in X-ray itself.
No, without X-ray. So you don't want to go to X-ray and you want to see the defect.
No, even X-ray also it is not able to detect. It is very small porosity
No,
or
so it's again no X-ray again X-ray capability. Please understand no X-ray capability. Now X-ray how depth most of the X-ray is not possible to go beyond. So because of the profile or because of the voltage limitations, we can't see many of the things in normal X-ray. So CT scan X-ray is best, but it is very costly. So if you want to see, you want to reduce the rejection, it's a simple method. The component is less weight. You can weigh and check. Definitely porosity area porosity component you will have less weight. This is one easy way to. This is one easy way. And why the notion the blowhole is because of shrinkage, because of temperature. If the temperature is there, you can implement flow sensor, flow and temperature sensor.
The temperature we are maintaining as per the standard temperature. This frame from Madras Engineering. I'm continuing with Mr. Subramanian sir.
Okay.
Am I audible?
So if you are maintaining the temperature within the band.
In the band, it is 660 to maximum we're going to 690. So it is
No, you are talking
regular
about the metal temperature.
Yeah.
Yeah. The metal temperature control, one is metal temperature control, again the mold control. The mold temperature control is important. In the mold temperature, again, fixed die, moving die, the variation should be very minimum. For that only, I have shown flow meters. The flow meters, which is controlling the die temperature in controlled way. That is that thing you can implement, so that you
What is the
can
temperature
able
you
to
are suggesting, sir?
in,
For
in
the
the
die
die
temperature. The
die
die.
temperature normally 170 plus or minus 30, but in your case the shrinkage is you need to check. So 170 plus or minus 30 is normal die temperature recommended by NOTCA. So you need to understand where you want to operate, minimum side or maximum side. So you should understand 170 to 180 or 170 to 190 within plus or minus 10 degree you can control.
Okay, sir. Actually, we require that we want to identify the defect before machining itself. In X-ray
No, why
also
you
we
want to?
checked. Sir, explain.
No, why you want to identify the porosity before machining? You just to eliminate it, just to remove it. You achieve 100% good castings.
Yeah, sir.
Then
Actually, sir, we are maintaining the same parameters, but the rejections are coming.
the die
The
temperature,
parameters are we are maintaining a standard temperature. In that batch, it's getting one batch is getting okay. In the same parameter, if again we are running, we are getting the defects. So that is what we are surprised.
Okay.
So
So how big
the criticality
how big
we want to
how big the
tell me, sir.
porosity? How big the porosity or shrinkage?
Porosity will be around maximum of 1 mm.
1 mm.
Yeah.
Then the best solution is this is like a pepper porosity. So you can implement skews.
Use method.
You can implement skews. So skews will give So you need to understand the porosity. You have to know after machining the porosity is a regular shape or irregular shape. You need to identify. Okay, if the shape is regular, for example round, it is gas porosity. If the irregular shape, the porosity, when you see in the zoom lens, it shows if it is irregular size, it is a shrinkage. So for shrinkage, you have to implement skews or less than 1 mm shrinkage defects. You need to implement skews. If it is no, you check the no component, you identify is it no round shape? It is no purely air entrapment. The air can be entrapped through your die coat or moisture or no your no oil, whatever this thing. So the shape you need to first identify it. You should understand is it clearly round shape or irregular or regular shape. So accordingly, you need to improve air venting or you need to implement skews. First, you need to understand. If the color, the shape is round, at the same time, the color is brown or dark brown or light brown or black color, it is oil contamination. This oil is creating the gas porosity. If the hole is round and very clear in color, same color, aluminum color, then this is that is called air entrapment, air porosity. Air can be through water or your die coat, whatever it is, or poor venting. So you need to check venting. So you just you find you collect the rejection components, and you can see through zoom lens. The lens is available. Small zoom lens is available. You can check and identify how many each and every batch the shape is regular or irregular. Sometimes it is coming round shape. Sometimes it is coming irregular shape. Means
Irregular.
you are
Irregular.
you are facing both the problem venting and shinkai. So accordingly we need to work.
Okay.
So you can get my email ID so that
Okay, sir.
you can contact me, send some photographs. You no, we will work together and achieve zero defect.
Okay, sir. We will call you, sir.
Okay, fine.
Any more questions?
Hello.
Hello.
Yes.
No, sir, I asked the audience actually if they have any more questions. If they
Okay.
don't have any questions, actually, we can wind up the session.
So
With the vote
whatever
of time.
questions whatever questions they can text to you so that you can send to me. I will try to
Surely, sir.
give.
Surely,
Yeah.
sir. Surely.
Thank you.
Thank you, sir. And on
Thank
behalf
you.
of Indian Institute of Foundrymen Chennai chapter, actually, first and foremost, actually, I extend a heartfelt gratitude to Mr. Durai, sir, actually, for sharing his deep knowledge and expertise, actually, as a die casting expert. Your presentation was truly enlightening and has given us valuable perspectives on the role of automation in ensuring quality and efficiency in the foundry industry. A special thanks to all the participants for joining us today and making the session interactive and engaging. Your active involvement is what makes these sessions, knowledge sharing sessions, very meaningful. With that, actually, we conclude today's session. Thank you once again, and we look forward actually to meeting you in our upcoming programs. Have a great evening ahead. Thank you. Thank you, sir.
Thank you. So Lakshman put your question that he want to supply details for casting stage final inspection. So I don't know. No, they want to know third party inspection or he want to implement. He want to implement local sensor in the shop floor. I don't know, but he can give more elaborate the question so that I can give record details. Average minimum cost will be required for this auto inspection for casting and machining parameter. So Mr. Nagarajan VJ, he asked what is the cost. No, he's again how
Yes,
many
sir. Yes.
parameters you
No,
want
isn't
to
any.
no
I'm
for
asking. I'm asking the standard parameters. That is for any minimum profile of
yes,
casting. What is the minimum cost of
yeah,
this auto?
minimum cost maybe 3.5 lakhs, 3 to 3.5 lakhs. If you have some facility with respect to machining, you want to fit some station everything. The sensor cost is very very cheaper. Maximum sensor cost is 35,000 maximum. So most of the maximum sensor cost is 35,000. No, most of the sensor that color sensor is 35,000. All other sensors are less than 35,000. Even from it is starting from 2,000 rupees. It's a good quality.
So,
The
package
total how many sensor you are going to use? How many photo
parameters.
sensor you? Yeah,
Yeah.
that is the cost. Maximum sensor cost will be maximum 1 lakh. So another you want to place the component repeatedly in the same area. So you need a fixer. The fixer this one and checking. So you want to go for real mass production without supervisor or without trouble. You want to do inspection. So every day you want to know every shift you want 1,000. Every day you want to 3,000 like that. Then you want good good standard facility. So that cost will be around 2 to 2.5 lakhs.
Yeah, okay. Okay, understand. What is your recommended of sensors the life, shelf life, how much it is coming for once it's implementing?
Again, repeat the question.
Now, what is the shelf life of all the sensors working for the life? Because once you are
No,
installing that,
that is no. So normally the sensor is generally the sensor where the lighting the flashing is coming there the sensor life will be little less maybe 6 months. But without flashing most of the sensor without a disturbance that will give good this one maybe 5 years 6 years also we can get it. So laser sensor, the life is more than 5 6 years. So far, I have never faced the sensor failure.
okay, okay. Thank you for that.
Thank you, Senthil. Can we close? Another 4 minutes is there.
Yeah. So we can close, sir. No worries, sir. Thank you,
No,
sir. Thank you.
still 25 participants are there.
Since actually you're
So
talking,
I
I think
want.
they were there. By already asked them actually if they have any questions, actually they can shoot up the questions. And then after vote of thanks, we got 2 more questions. But if anyone wants to raise some questions actually to Durai sir, still, but otherwise we can close it. Sir, I think we can close it, sir. Thank you very much.
Fine. Thanks, ma. Thanks for everyone.
Thank you, sir. Thank you.
So this is a Bagul. Communicate to Bagul. No, Bagul not. Huh? Bakul, no, communicate to Bakul. Bakul only, made this happening. This, you, Senthil, you communicate to Bakul and Prabharan, sir. Thank you.